The Decimate modifier allows us to significantly reduce the amount of topology on our model. In order to access the Decimate modifier, select your object, then go to the Modifiers tab in the Properties panel. From here, click on the Add Modifier button, go to Generate, and then select Decimate. Now the Decimate modifier is being used on your object, but there are three main methods for the Decimate modifier. Each of these methods is comparable with a specific tool in Blender. The three methods are Collapse, Unsubdivide, and Planar, and they all have their own unique set of parameters. The Collapse option is similar to that of the Dissolve tool. In edit mode, you can select your geometry. For example, we can select this geometry here. We can press the X key to bring up the delete menu, and then we will have the ability to dissolve vertices, edges, and faces. The collapse method for the Decimate modifier will work in a similar way, but will do so based on its parameters. So in the case of our dissolve functionality, if we choose to dissolve the faces, we end up with a single face where there were once many. The unsubdivide option is similar to that of the unsubdivide tool. You can locate this in the edge menu, come down to the subdivide section, and then select unsubdivide. The idea here is that you can significantly reduce geometry by performing a tool that is effectively the opposite to subdivision. In this example, I've been able to successfully unsubdivide the geometry of my model because it had recently used the subdivision surface modifier in the first place to add that geometry. It will not look this clean in every case. Keep that in mind when using the unsubdivide tool, both in the tool itself and, as we will soon see, the Decimate modifier. I'll use Ctrl-Z to undo that, and the last option is Planar. This is most similar to the limited dissolve functionality. Again, if I press the X key to bring up the delete menu, there's an option here for limited dissolve. If I left click and open up this area down here, you'll see that we have the max angle, the all boundaries parameter, and the delimit options. This is extremely similar to what we see in the Decimate modifier. So these are the three tools in which are comparable to the Decimate modifier. But what about the modifier itself, and how do we use each of these methods? The collapse method allows us to effectively dissolve our geometry depending on the parameters below. The primary parameter for this method is the ratio. When set to 1, the Decimate modifier is not actually doing anything to our model. This ratio can go between 0 and 1. 1 represents the original geometric count, and 0 will represent the minimum geometric count possible. If you take a look at the bottom here, you will see the face count. This represents the current number of faces on our object after these settings have been applied. You will also note that in unsubdivide and planar, we can also see the face count. So this is the one thing in common between these three methods of the Decimate modifier. If I click and drag on the ratio, you'll see at the moment that nothing is changing, and the reason why is because, like many modifiers by default, they do not actually affect the model in edit mode. Now this one doesn't actually have a button to allow us to use it in edit mode, so we need to go back to object mode to view this. Again, I'm going to click and drag the ratio, and over time you should begin to see the geometry of our object change. Eventually, if I bring it all the way down to 0, we get something that is completely unrecognizable. because our face count has now been brought to 0 as well. So you'll want to bring this down to the lowest possible count without distorting the structure of your mesh, at least to the extent where it starts to become unrecognizable or unusable. So in this example, a ratio of 1 uses 7,872 faces. If I bring the ratio down to about 0.3, which is probably the best that we're going to get before it starts to distort the object shape, this brings our face count down to 3,597. The next option is for symmetry. Now, this would actually be easiest to demonstrate on something that is perfectly symmetrical on all 3 axes. So I'm just going to hide Suzanne for the moment, and I'm going to bring in a UV sphere. Then I'm going to add a modifier, which is going to be the Decimate Modifier. And then I'm going to enable symmetry. But before I do that, if I take a look at my object from a front orthographic view, I'm going to decrease the ratio, and you'll see that over time, we're able to generate new geometry by dissolving what was there before. But this isn't symmetrical to any point, so it's not the same look on either side of the x-axis, for example. If we want to adopt a similar look or a mirrored look along an axis, we would need to enable symmetry. If I click this option here, you will immediately see that the geometry has shifted, and actually we can now see a line going down the center. So this indicates that we are now mirroring the geometry on both sides of this line, which is at the center of the x-axis. Now if I set this to the y-axis, I would need to change my view so that we can get a good look at exactly what's going on here. Again, it's very similar to the x-axis, where both sides look very similar. They're just mirrored along the middle line. And then finally, we have the z-axis, and this shifts the line to here, so almost like the equator of the object. And you can tell that one half of the UV sphere is effectively the same in terms of its appearance as the other one, just mirrored. If we return to Suzanne, I'm just going to select Suzanne so that we're using the modifier attached to the object. And let's say we're looking at this from our front view. So in this case, we'd probably want to mirror the geometry on the x-axis, which is not currently the case. You can see it's quite different on each side. In this case, I will just enable symmetry and make sure it's set to the x-axis. Now, as I manipulate the ratio value, it will maintain the same geometry on each side of the x-axis, just in a mirrored state. Underneath the symmetry, we have the Triangulate option. Now all this will do is it will ensure that when we are using the Decimate modifier, any geometry that is generated is going to be made into a triangle, a three-sided face. So all we need to do here is tick this box, and you should see there's a subtle change in some of these faces. And all that's happening here is that we are locating the geometry that is effectively four sides or more, and we're just converting that geometry into triangles. This can be useful for certain applications, such as in game design, where objects are treated with their geometry as triangles rather than quads or n-gons. Moving back to the sphere, we're going to demonstrate vertex groups. We can assign a vertex group, and then the Decimate modifier, when using the collapse method, will only affect geometry within that vertex group, or only affect geometry outside of it. For this example, I'm just going to turn off symmetry and triangulate, and for the moment just bring our ratio back up to 1. I also need to be careful because I've just done that with Suzanne. Now that's okay, but I'm going to have to go back to my sphere object and basically do the same thing. Just make sure everything is set to the default. Then I'm going to go into object mode or edit mode, and for this example I'm going to choose the top vertex, hold shift and select the bottom vertex, then I'm going to hold down control and press the plus key just a few times, and the geometry that I have here is going to be my vertex group. So I'm going to go into the data tab in the properties panel, add a vertex group. I'm going to name this as pole or poles, since we're using both north and south, and click assign. Now I'm going to return to the Decimate modifier, move into object mode, and I'm going to assign the vertex group poles. Now we're going to change the ratio value, and as I decrease this, you should see very quickly that the area of the object that was not assigned as part of the vertex group is no longer being affected by the Decimate modifier. We've actually reached a limit to what we can do with this modifier because the vertex group prevents us from manipulating the geometry that is in the center of our mesh because it's not part of that group. Alternatively, we can reverse this using the invert button. So all we need to do here is left click to invert, and now it just affects the geometry in the center of our object that was not a part of the vertex group. I'm just going to have to increase that ratio so that we get something a bit more presentable, but that's effectively how we can use vertex groups to control which areas of our mesh are going to be affected by the Decimate modifier. Returning to Suzanne, I'm going to now create a vertex group for Suzanne. So I'm going to move into edit mode. And I think all I'm going to do is I'm going to use control and plus until I cover the face. So at the moment, that's a little bit too much of the model. But for now, it should be good for our demonstration. Actually, I am just going to change up my methods. So let's use the C key. And all I want to do is I just want to select the area that we can see from the front. Doesn't matter if it's completely accurate for the example. So all I'm doing is I'm just selecting all of the geometry that makes up the front of the face for our model. And then, again, it doesn't need to be perfect. And then I'm just going to go in and I'm going to create my vertex group by going to the data properties, creating a group. We can call this face and then assign. Return to the Decimate modifier, assign the face as the vertex group, and then manipulate the ratio, which we will need to do in object mode. So click and drag. And now, for the most part, depending on how accurate you have been, it should begin to decimate or reduce the geometry of the face only. Again, if you want to reverse this, just click on the invert button and then manipulate the modifier in the same manner. So here we can reduce the geometry of the head area whilst maintaining the geometry of the face as required. Just in case you're finding it difficult to view your geometry as you play with these settings, you can better view the edges by going to your Viewport Overlays menu, come down to where it says Geometry, and then tick this box next to Wireframe. Now it better displays the edges in object mode, and if we play about with the ratio, you should get a better view of exactly what's going on when using the Decimate modifier on your geometry. The last value here is the factor, and all this does is it determines the strength of the vertex group's influence using the Decimate modifier. Now this may change in its effectiveness depending on your use case. In this use case, for example, which is a relatively simple model, manipulating the factor doesn't really do much unless we turn it off entirely. And if we turn it off entirely, then it begins to manipulate some of the geometry that is not a part of the vertex group. Now let's move on to the second method of using the Decimate modifier, which is to unsubdivide our geometry. This only has a single parameter, the number of iterations that we can manipulate. Again, this is the reverse of the subdivide tool and typically works best on any model that has uniform geometry that is primarily using quads. So if you have a complex mesh that uses a variety of triangles, quads and n-gons for your faces, then this may not function as you would like. The Suzanne model is mostly clean in terms of its geometry, and it has been affected by a subdivision surface modifier previously, so there is more geometry than what there was before. When we have the iterations set to 0, this means that the unsubdivide functionality is not actually being applied to the model. We can increase it to 1, and this will increase the effect that the Decimate modifier has and lower the face count, but it will attempt to do so in a uniform manner. Now, if you take a look at this, you'll see that the faces themselves and the topology has been distorted, and you're going to find this to be the case in a lot of examples where you use an odd number of iterations. So we have it set to 0, and pay close attention to in between the nose and mouth. You can see just how uniform the geometry is here. And then as we set it to 1, it almost ends up with like a cross-like fence pattern. If I increase it to 2, then it's more clean like the initial model, but this time we actually have it so that there is far less geometry on the object as a whole. You can see here the face count has been reduced to less than 2,000. So when set to 0, we're just under 8,000, and set to 2, we're just under 2,000. And we can keep increasing the number of iterations until we reach the state that we are looking for. So here, it looks as though we're pretty much where we were before we would have added the subdivision surface modifier to Suzanne. There were probably a couple of slight changes, but this is basically what we would have had initially when we used the subdivision surface modifier, and unsubdivide is almost a way of reversing that operation if used correctly. The third and final method of using the Decimate modifier is the Planar method. Here we effectively use limited dissolve style functionality to reduce the geometry across our model, depending on either the angle limit or the delimit values here. So first of all, let's take a look at the angle limit. This value basically determines the angle at which a specific edge or face needs to be in order to be dissolved. As we reduce the angle limit, we actually reduce the number of vertices and edges that are going to be dissolved as a result of the modifier, because there are fewer edges and vertices that are going to fall below this value. If we begin to increase the angle limit, then more of our faces are going to fall underneath this value and as a result are going to be dissolved. So if we set this even as high as around 18, the face count of the model decreases dramatically to as little as 500. So this can have a substantial effect on our model very quickly. For now, I'm going to reset this back to 5. The delimit options underneath of the angle limit act as limiters or restrictors to the decimate modifier. It helps to prevent the dissolving of geometry where we want that geometry to be maintained. Now the first option here is for the normals. The best way to demonstrate this is to go into edit mode for our model and then click on the mesh edit mode overlays menu. Down here we have the ability to view normals. So I'm going to click on this third button here, and that's going to allow me to view the normal direction of each individual face on my model. The idea here is that when we turn on the delimit option for the normal, any of these faces that are pointing the opposite direction will, to an extent, not be dissolved. Now this doesn't always function in the manner that you would expect, but we can demonstrate it here. I'm going to press the C key and I'm just going to select a variety of faces. Then I'm going to use Shift and N, and I'm going to recalculate the normals for these faces on the inside of my object. So you can no longer see the blue lines coming out of these specific faces. If we go inside of the model, then you should be able to locate those same blue lines which represent the face normals. Now I'm going to return to object mode, and let's just increase the angle limit to 9 degrees. So this is the effect that we've got, and keep in mind that this is the area in which we reverse the normals. Now keeping an eye on this area, let's see what happens when we manipulate the normal delimit option. You can see that more of the geometry has been maintained. The general shape and direction of the normals has pretty much been maintained here as well. Now this does not maintain the faces in their initial structure, it simply attempts to preserve the general structure of the area. The next option that we have is to delimit based on the material. Now to be more precise, what this means is that wherever there are two faces that have different materials that are adjacent to each other, then Blender is going to attempt to maintain that edge for as long as possible, depending on the angle limit. To best demonstrate this, I'm going to go into Material Preview, and for our example, I've basically created 3 materials. Red for the head, blue for the outside of the eye, and then for the pupil we've got, or the iris I should say, we've got the black colour. Now what we are going to focus on here is the transition from the black material to the blue material. This is the area that should be maintained when we use the delimit option for our material. So now I'm going to set this to material and then increase the angle limit. As I do this, you should see that for the most part, the material color is maintained as well as the material shape. Now, if I was to change this back to normal, you can actually see that we start to get a bit of distortion in areas, so it doesn't quite maintain the initial shape of the geometry when we created the material. Now, if you go too high with this, then eventually the amount of geometry you have available will distort the look of this area of the model regardless. But again, it's a way of preserving important details on your mesh, in this case depending on where the materials have been assigned. The next option is for the seams. Now seams are typically used for when you want to control how you can create UV maps for an object. We're going to explain in a minute why this is different from the UVs option. But for now, I'm going to go into edit mode. And from here, I'm just going to go into edge select, alt, left click, and we're going to select this edge loop right here. I'm then going to use Control and E to bring up my edge menu, and I'm going to mark this as a seam. The idea here is that when we set the delimit to seam, this edge loop should be maintained as best as possible. So if we return to our object in object mode, I'm just going to turn up our angle limit to about 8.2, and then we're going to swap from material to seam. As soon as I do that, you should see that the edge loop has indeed been maintained, and it's been maintained very well, all the way up and down along the length of our model. So pretty much everything that we had marked as a seam has been maintained in this case. Now again, eventually you may see that some of the geometry dissolves to such an extent that we start to lose that edge, but it does attempt to maintain that edge loop, that seam, for as long as it possibly can, depending on your angle limit. The sharp delimit option operates in a very similar manner to the seam option. The only difference is, as you might have guessed, is that we would need to mark edges as sharp instead of seams for this to function. So if I first of all change this from seam to sharp, and I'm just going to reduce the angle limit back down to 8 degrees, you can see that we lose that edge for the most part going along our model. A bit of it is still maintained, but that's probably still just the Decimate modifier itself attempting to maintain geometry where appropriate. Now we're going to return to edit mode, and I still have my seam selected, so all I'm going to do here is bring up my menu and clear the seam. And now if we go back, we can see at the moment that we don't have that seam or that edge loop going all the way across. But let's now add the sharp parameter to this edge or edge loop. So now it should appear as blue. We're going to hit the tab key to move back into object mode. And now you can see once again we've been able to maintain that edge loop all the way around because it's marked as sharp, and we're using the sharp delimit option to maintain it. Let's try it with another loop. So maybe we want to maintain the facial structure going all the way around. Again, Control E, mark this as sharp, and then press the tab key. And again, you should see that even with the Decimate modifier in effect, we can still move around our model and we can still follow that edge loop that goes all the way around the edge of the face. So you can create as many seams or sharp edge loops as you want, and the more you create, the more information the Decimate modifier will have to try and maintain your geometry's structure whilst also lowering the topology count. The final option for the delimit is the UV option. Now all this effectively does when we change it, you'll see a minor difference there, is it basically ensures or attempts to maintain the structure of our geometry based on any UV map that may have been created. Now for Suzanne, a UV map is created by default. If we go to the UV editing workspace and then select all of our geometry, you'll see that we have the UV map here. And all the delimit option does is it defines the boundaries of each of the UV map islands, so things like these vertices here, and it will attempt to maintain this structure when the Decimate modifier is in effect on the model. Again, the higher your angle limit, the more likely you are to break up the geometry even at the UVs, and we've seen that with all of the delimit options. They do not 100% prevent the decimation of that geometry, it simply recalculates it so that that geometry is going to be maintained for as long as possible as we increase the angle limit value. But again, when you set your delimit option to the UVs, this takes into account any current UV map that you currently have for your model, and it uses the boundaries of the UV map islands to determine where the geometry or topology should be maintained for as long as possible. The final option that we have is a checkbox for all boundaries. So this basically dissolves the vertices that you would find along specific face boundaries, and that may sound very similar to what just dissolving is. But the difference is that it can attempt to get rid of redundant vertices and better clean up your topology. This is very useful if you want to increase your angle limits to a higher value. So for example, I'm going to set the angle limit to 15 degrees, and that gets rid of a lot of our geometry. Now watch what happens to the face when we click on the all boundaries option. There's quite a significant shift in our geometry. So here you've got a lot of these jagged edges on our models, and to be honest, they're a little bit redundant. So if we turn on all boundaries, we just get a straight edge, where before we had this jagged line. And the reason why this is the case is because with all boundaries, we're effectively dissolving any of the vertices that, as we said before, are effectively going to be redundant in that position, and it just attempts to further clean up the topology. Again, this works much better when you use a higher angle limit with a lower face count. That basically covers everything that you need to know about using the Decimate modifier, its different decimate methods, and the parameters associated with those methods. I hope you're now more confident in using the Decimate modifier and just have a general understanding as to how each of the methods are designed to work to help improve the geometric count of your model when working on a specific project. Remember, there are many different use cases for the Decimate modifier, such as improving viewport performance temporarily while it's active, to improving performance of renders by reducing your topology with highly detailed sculpts. But that's all from me for now. Keep an eye out for future videos as we attempt to cover more tools and modifiers used in Blender 3D. Don't forget to like, subscribe and turn on the notifications icon, and I will see you in the next video.